Hello everybody. Let's do solutions to problem set 3 because looks like I haven't made a solutions video yet in a previous year. So the first set of problems are taking the idea of the max method that takes some inputs and returns a maximum value and extend it to 3 inputs or optionally 4 inputs. So there's a couple nice ways to do this. First, let's just make the regular max method. I like to program by intention, so I'm going to output max of 2 and 3, and we have a compile time error here because I haven't defined the max method yet. So here I'm going to go ahead, this wants to import a max method, but I don't want to import it, I want to make it myself. So public static, it should return a double, or did I say int? I said int in the problem set. And then I have 2 inputs, A and B. So I could just make a wrapper for math.max, which is a built-in max function. So that would be an easy enough way to do it. Let's just run it to make sure it works. Okay, so that's returning 3. So a nice way to extend this, so let's pretend I wanted to have a 4th input. Now, again, it's sort of not defined. So I'll copy this. Whoops. Okay, so now I have a version. It's also called max, but now it has 3 integer parameters. And this is called method overloading because I've overloaded the definition of max. There's 2 different definitions. There's max with 2 int inputs, and there's max with 3 int inputs. So that's called overloading. And a really clean way to do it would be this. I could say find the maximum. Well, here, let's do it in a couple of steps. So I could say find the maximum of A and B, and now let's return the maximum of either C or whichever was larger of A and B. So it's like whichever of these is larger, I'll save it here, and then I'll compare that largest value to C, and I'll return the largest between those, and so that'll be the largest of all of them. And you don't need to store it into a temporary variable like this. You could just paste it there. So we could not there. We could just nest it like that. And this will do the same thing because we're going to evaluate the maximum of A and B and then take whatever return value that does, and then that becomes the input to math.max here. And so you can chain that as many times as you wanted to. If we wanted to do a version that accepts 4 inputs, you could also do that. So here I could say math.max B and D. Here, let's make this a little bit more organized. Okay, so I find the maximum of C and D, compare it to B, compare it to A. So that would work. A different approach to this that I saw some people doing was this. They had like a max so far, which they set to something very small. Or actually, let's set it to integer.min value. Integer.min value is the smallest possible value for an integer. You can see when I hover over it here, it's like about -2 billion. And so then I'll say if if A is larger than, or here let's just set max so far to be A. That's going to be even better. So now we'll say if B is larger than A, then I'll set, if B is larger than max so far, then I'll set the new max so far to be B. And now if C is larger than that, then I'll set the new max so far to be C. And then if D is larger than that, I'll set it to D, and then I can return max so far. So I initialize the maximum so far, assuming it's going to be this first one. But if it's not, that value will get replaced later on. And then I test each one to say, is the next one larger? Is the next one larger? Is the next one larger? And so by the time I get to the end of this, max so far should contain the largest of all the values I've tested, and I've tested all the values. So that's another nice approach that you could have used. Okay, let's do the next one. So problem 2 asks you to compare display end times, where you'll loop and display this string that many times, and then get repeated message, where we're not going to display anything. Instead, what we do is we return a string which consists of this many repeated copies of the input string. So let's do both of those. So display end times, bird. Fingers are not so nimble today. And then I'll create the method. Just to remind you what the hotkeys were, I hit Alt-Enter. I don't want to name this bird because that's silly. Let's call this display string, or let's call it message. And then this is, I couldn't call that n because n is a normal variable name when you're looping something a certain number of times. So now I'm going to use for I, and I'm going to loop up to n times. And remember, the standard pattern for looping n times is you start at 0 and you have your loop counter be less than the number of times you want to loop. So that really is looping n times. And then I don't actually want to do this. I could do message. And you'll see that this will display bird, bird, bird. There it is. But if we look carefully at the problem statement, it's supposed to display all on one line. And paying close attention to detail is really important in programming and important in the AP test. So just to remind you, if I print, I don't include that ln. The ln is what moves it to the next line after it's printed the message. If I just have print, now it will all display on one line. And that, I think, satisfies the prompt. I forget whether the prompt says that you should go to the next line afterwards, but you could do that as well. So I have a blank, I have a blank line at the end here. So it'll print bird, 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 and then move to the next line. Okay, so that's display end times. Now let's change this to get repeated message. Same thing. Okay, so here what I want to do is I want to build this string up piece by piece. So I'm going to call it output, and it starts as the empty string. It starts containing nothing. And then I'm going to loop n times the same way I did before. And then each time I want to attach or append another string to the end of the output. So I'm building it up. So what I want to attach is message. And then I want to return the output. And you'll notice I'm not actually printing anything here. Oops, it's supposed to return a string. So this is the return value. And then if I'm returning a string, the return type here, which happens right before the method name, has to match the type of the variable that I'm returning. So if I run it, you might say, well, wait, it's not doing anything. Here it is running, and as you see, process finished, but I didn't print anything. But that's because there are no print statements anywhere here. You can see what it's doing if you'd like by adding a breakpoint, by clicking in the margin between the line numbers and the editor pane. And then you can click this little green bug button that runs it in debug mode, which will pause as soon as it reaches this line. So it's still running, it's just paused. And now I've got two buttons here. I've got this step over and step into. We're going to step over. And each time I click this, it will run one more line of the code. So you can run it one line at a time. So here I ran it, and then you can see right now it's displaying the current value of the variables. So output right now is the empty string, n is 3. Let's click next. I is 0. And now you can see that output has become bird because I've looped one time and I've put my message, which is bird, and I've attached it to the end of output, which was nothing. So you can watch, there's another bird, and now I'm at the return statement, and I exit, and I'm done. So you can click the red square up here to stop the execution. I can uncheck the breakpoint. It's a little bit weird to return a value here without doing anything, so I'm going to say answer gets the return value of that. So whatever this returns now gets stored into answer, and then I can print it to see what the answer is. And there it is. Okay, let's do the next one. Okay, so next we've got problem 3 has a bunch of string methods. We've got weave strings. And reading the problem statements is a big part of programming also. So you have to sort of look at the inputs, you have to look at the output, and you have to understand how does the description of what the method is supposed to do fit with the inputs and the outputs that are the examples you're seeing. So here, if I give it A and B, it displays B, A, B, A. So it looks like it's displaying this followed by that, followed by this, followed by that. Same thing here. Hi, kebab. It says kebab, hi, kebab, hi. And then the general description says display second, first of the arguments. So let's start there. Again, programming by intention. I will print line, and then I'll say weave strings. And then let's just do the AB example because I think that's a little bit clearer. Capital A, lowercase b. Okay, so now I'll hit Alt-Enter. It says create the method. I don't want to return Boolean, so it's guessed wrong about what I want. I want to return a string. And I guess we can call them A and B. That's fine, because the first and the second don't really have an intrinsic meaning. And that's easy enough. Oh, it's not supposed to return anything. My mistake. It's supposed to display something. So we'll just do that, and this can remain void. So all I need to do is print line B, print line A. Oh, except not print line, print. Print B, and then print A. The last one, I'll make a print line. All right, so that should work. Great, BA, BA. So the next one, part B, it says same last letter. So I'm just testing if the last letter of if the two inputs is true. So this one I will display same last letter, blink, and sync. So we're expecting that to return true because K is the same as K. So in this case, I do want to return a Boolean because the output is true or false. I'm going to call this one A and this one B. And I could do an if statement. There's going to be a shorter way to do this, but I could say, well, let's do a couple of wrong things first. So I guess the first thing I have to do is like get the last letter. So several people discovered that they can do char at. Yes, you can do that, but it's not part of the AP subset, so we're not going to do that. Instead, we're always going to use substring. Substring will get out a certain range of letters in a string where you give it the starting location and the ending location. So if I want the last letter, I need to start at the very end of the string, which is a dot length minus 1. And then there's, let's actually really break this into little tiny pieces before we combine it. So let's do last letter 1 is going to be a dot substring, and I'm going to get the last index a dot length minus 1. So a dot length minus 1 is the last index. If I ask for the substring starting at the last index, it'll start there and it'll go all the way to the end of the string, which is what I want. So that's going to give me the last letter of the first input. Let's do last letter of the second input, where I've changed it all to B. And now I can compare the last letters. So you might think you could do this if last letter 1 equals last letter 2. Just a thing to remember from last year is you can't use double equals for strings. And IntelliJ knows if I hover over, it says string values are compared using double equals, not the equals method, and that's wrong. So if you want to compare strings, you have to say dot equals like this. So if they're equal, I'll return true. Otherwise, I'll return false. Let's start making this shorter now. So if this statement evaluates to true, I'm returning true. If this statement evaluates to false, I'm returning false. So one way to make it shorter is I could just say return whether or not it's true that last letter 1 equals last letter 2. So this one line does the same thing, because if this statement is true, I'm just going to directly return true rather than say, if it's true, return the literal true. So that's made that shorter. To my eye, this looks the cleanest. But if we wanted to, we could like substitute this in here for last letter 1, because that's what last letter 1 equals. I substitute this in for last letter 2, and now I have a solution all on one line. Don't be fooled, though. Having a solution all on one line is not, like, the goal of programming is not to have the shortest code. It's to have the easiest to read and think about code. So this, I think, is a lot harder to look at and think about than what I had just a minute ago, which was that. So I like this as the solution. Okay, let's do part C, which is double display. Here it says display each input character displayed twice. So double display. Let's do hey. Program by intention. Oops. So, again, I'm not going to display anything. Okay, great. So it's a void method because it's going to display itself. It's not returning anything. And then I'm going to call this message. So if I want to display each letter twice, I think I need to loop through each letter one at a time, almost like this is an array list. So let's do that. So for I goes from 0 up to message.length. So this is like all of the locations in the string. And then let's get out the letter I want to display. So here I'll say message.substring. But this time I want to start at location I and end at location I plus 1. So think about how this makes sense, like in a substring, in an array list. In an array list, I would just say get the element at index I. Here I'm saying get a range of elements starting at I, ending at I plus 1, but it doesn't include I plus 1. And you can code trace this in a second if like this is too abstract to think about. And then what do I want to do? I want to display it twice. So let's display letter. So I could have two print statements like this, or I could display letter plus letter. So I'll just display it twice with one print statement. Let's put a breakpoint here and we can see what this is doing. Okay, so I've seen that it displays the right thing down here. Let's run it in debug mode. And we can see the letter is H because I was 0. And then it's displayed HH. I think, can we go to the console? Yeah, so if I go to the console, you see it's just displayed HH. And now here we are back in the debugger. And then when I is 1, now letter is E. So I've gotten out index 1 from the original input hey. So you can trace through that if you want. Okay, what's next? Next is D through F. Okay, here we are, solutions, problem 3, D through F. So we have insert, which is going to insert a string between every letter in the first argument. I guess let's start there, and then it returns it, right? Or does it display it? No, it displays it. Okay. So insert, and then I'll say hello there, and then dash. So I'm going to program it a little bit wrong the first time, and then we'll fix it. Oops. Okay, so public static void insert, and then string. I'm going to call the first input message, and I'm going to call the second input. What's a good name for that? It's called a delimiter, but you probably don't know that word. Let's call it. Let's call it between. It's not the best name in the world. Okay, so if I want to insert something between other things, I'm not actually inserting it. Like really, it says I should display the first letter and then between, and then the next letter and then between, and then the next letter and between. So this is almost like the last problem where we had to display each letter twice. So I think a good starting place would be, let's loop through each letter the same way that we did before. So I'll loop location numbers from 0 up to the length of message. And then let's get out each letter from the message. So I'll say letter equals message.substring from I to I+1. And a good thing you can do while programming is you can run the code as you're going to make sure it does what it's supposed to do so far. So I'm just going to print so far letter. And what I think this is supposed to do is it's supposed to get out each letter one at a time and display it. And so now if I run the code, I'll see if that actually works. Yeah, so it says hello there, and that's what I was expecting it to do because it says hello there. And another thing I could do is like I could try and print each letter followed by a dot. Even though that's not the goal of this problem, this is me just making myself feel good that it's doing what I expect it to do. So you can sort of tinker a little bit if you're feeling uncertain to give yourself confidence that your code is doing what you expect it to do. So we're almost done here. In the last problem, we just printed each letter twice like this. Hello there. In this problem, we don't want to print each letter twice. We want to print each letter followed by whatever this intervening string is. And so as you can see, this is almost perfect. I've got hello there. The only problem is I have this one extra dash at the end. And I'm not supposed to have an extra dash at the end. So here's the cheap way to fix this. The cheap way to fix this is let's end one letter early. So instead of looping to the very end of the string, I'm going to loop to the very end of the string minus one character. So if I run it now, you'll see I've got hello there, but I'm just missing the E at the end. And so since I'm missing the E at the end, let's print it out at the very end. All I have to do is get the last letter out of message. So I'll say message.substring, except this time I'm going to start at message.length minus one, which is the last index. So again, conceptually what's happening is I'm looping through all the letters except the last one, and I'll display the letter followed by the intervening character. And so the last time through the loop, I display the R and the dash. Then I just want to display the last letter of message after the loop is completely finished, like to close out the problem. So I think that's a perfectly good solution. Let's go and look at E, which says count letter. So count returns the number of times a letter occurs in a string. So let's do that. Count letter. I'm going to count the letter A, and hey is for horses. Let's create the method. It's not a Boolean. I want it to return an int because it's a count. Let's call this message, and let's call this letter. So you don't really have to do any checking to make sure the inputs are valid inputs. If it's supposed to be counting, oh, I've got this backwards. Sorry, the first input is a letter. The second input is a message. So if the first input's supposed to be a letter, I might do something like check to make sure that letter is actually length 1. Because if it's length 0 or length more than 1, then the input wouldn't represent a single letter. But for these kinds of problems, we're not doing that stuff. So let's make a count that starts at 0. Let's loop through every letter and check to see if it's equal to the letter it's supposed to be. So for I, I'm going to go up to message.length. Let's get out letter to check is going to be message.substring I to I+1. And then we'll say if letter to check equals letter. The autocomplete is going crazy here. So if letter to check equals letter, then we'll add 1 to the counter, and then at the end we'll return the count. Let's see if it works. So this is displayed 1 because hey is for horses contains 1A. Let's try S in the same message. What's that, 3? Yeah. So there is 3 because we got an S for an S in is and 2 S's in horses. Great, so that seems to be working. Here's something I want to point out. All of these solutions so far have contained the same pattern, which is we have a for loop where we're looping through every single index of message, and we're getting out letters one at a time using substring. So that's on purpose. My problem sets, usually all the problems are related to each other, and like if you're trying to learn how to get better, you want to start thinking in terms of these patterns. So you want to realize when a problem involves looping over all the letters in a string, for example, and remember that substring is the way to access them. So a great way to study is to come back at the end of a problem set and try and like write down for yourself what were patterns that were the same in all of these, or what were important commands that were the same in all of these. Like substring, I showed you how to use it. But how did we use it? How did we apply substring to these problems in a way that we did over and over again? Let's do the last one. F is called weave2, where now we alternate, what is it? Okay, so first of all, the inputs have to be the same length, and then here we alternate first letter of first input, first letter of next input, first letter of this one, first letter of that one, like that. So speaking of patterns, the pattern here feels very similar to the other ones. So let's call this weave2, hi there, and then weave2, A, and B. Let's create weave2. It's void method because it's going to do its own displaying. Let's call this A, and let's call this B. Okay, so the first thing we need to do is check to see if the two inputs are the same length. And if they're not, exit. So a lot of people probably did this. If a.length equals b.length, then like do the rest of the method. That's okay. The problem with this is, like, one of the ideas of clean coding is you should have as few levels of nesting as possible. So if I have all the code in here, if someone's reading my program, they have to store in their own mind, like, this code is only happening if a.length and b.length were true. A slightly different way to do this, that's a little bit better, would be to say if a.length doesn't equal b.length, then return immediately. You might not have known that you can do this. So you can use a return statement in a method that's void. You just don't have a return value. So if I tried to say return a value, now it says cannot return a value from a method with a void type. But if you just say return will just exit the method right away. And that's what I want, because I'm saying if the two inputs aren't the same length, exit right away. And so now I can do the rest of the method here. And it's like we've already checked this condition, and so we don't ever have to think about it again. And that's slightly cleaner. And we'll talk about that more, as the year progresses. Okay, so let's talk about how to do this. It feels like very much the same pattern. It's like I want to loop through each letter one at a time. So let's loop through a.length, and let's get out the letter the same way that we did last time. And so now if I just wanted to print out letter, I could do this. So this is that same pattern we started all the other problems with. I loop through each letter of the input one at a time. I get the letters out with substring, and I'm printing them all. A lot of people might think, okay, I need to loop through every letter of A, and I need to loop through every letter of B. So you might be tempted to put another for loop in here. Or you might be tempted to put another for loop after. But the thing to realize is this for loop isn't actually looping over the string. All this for loop is doing is it's making the variable I take on every single starting number in this string. But since this string is the same length, when I equals 0 and let me just show you. So if I do b.substring, so a.substring I to I plus 1 will get like letter 0 from A. b.substring I to I plus 1 will get that same location number, but from B. And that's what I want to do, because really I want to get corresponding letters from each string. So I really just want to loop from 0 to 3 one time. But each time, for each number, I want to get out each corresponding index from these two different strings. So I've got letter 1, I've got letter 2, and now I can just print letter, followed by letter 2. And probably that does it. Let's just double check. So as you can see, hi there displayed nothing, as it was supposed to. And then here we've got A, B, A, B, A, B. Is that right? Yes, that's right. Great. Okay, done. Come back in a second for number 4. Okay, problem 4 is called count factors. Let's look at it. So I give it a number, and I'm supposed to count the number of factors of that number, where a factor is a number that's smaller than it, that evenly divides it. And so now I'm just reminding you how the mod operator works. Oh, great. So I have some pseudocode here. So here's the pseudocode. Because I'm supposed to count the number of factors, we'll make a counter variable that starts at 0. And then we're going to test every single number from 1 up to the input number. And we're going to test to see if the input number is evenly divisible by that test number. And if it is, we're going to add to the counter because we found one more factor. So let's go ahead and implement it. So count factors of 10, let's say, or let's count the factors of 12. It's got more factors. So I want to return an integer because it's a count, and then I'll call this num. And so I'll have a counter at 0. I'm going to loop I from 0 up to num. Do we want to include num is a question. Let's look at the input. So here, count factors 10 should return 4 because like 10 evenly divides 10. So if I is each factor I want to test, I actually want to go up and include this input number because that's potentially one of the factors. Or I guess we don't need to test it. We could start the counter at 1, just assuming that num always divides num. So either way would work. I want to keep it this way. But the point of that is attention to detail. Like I said before, you have to think carefully about like first cases, last cases, things that are unusual. Like double check the details carefully. All right, so now I want to test to see if num is evenly divisible by I. So the mod operator will tell you what's the remainder when this is divided by that. So if num is evenly divisible by I, that means the remainder should be equal to 0. And that's how you test the divisibility. So if it's equal to 0, then num is evenly divisible by I, and I'll add to the counter, and then I'll return count. And then what's it say here? Division by 0, cool. So speaking of attention to detail, if I start I at 0, I can't divide by 0 because that's mathematically undefined. And so let's see what happens when we run it, actually. So here it says arithmetic exception, division by 0. And hopefully if I'd done this, if I hadn't thought about that, I run it, I see I've got a problem. I'm like, oh, where's the problem happening? Right here. So I click on line 12, and I'm like, oh, okay. And then IntelliJ is like really helping me through figuring out what's going on here because it's highlighting stuff that's wrong. So I don't want to start I at 0. I want to start it at 1. And so now we can run it again. Cool, 6. Is that right? Let's count them. So factors of 12 include 1, 2, 3, 4, 6, and 12. So that's 6 factors. So that's true. It should be 6. If we wanted to make this ever so slightly more efficient, we know that numbers are always divisible by 1. So we don't have to start at 1 and test it. We could just start at 2 and just start the counter at 1. Because we assume that 1 is already in the count. And then we could not include the number itself and start it at 2. Because 1 and the number itself are always evenly divide the number. And so we start the count at 2 and we just don't check those two. And so that should give us the same result. So like let's choose a prime number like 7. So 7 only has 2 factors, 1, and 7. And we run it, and indeed, there it is, 2. All right, let's do part, what was that? Let's do part, I guess there was no part B. Was there part B? Guess I removed part B. Okay, so let's write a method called isPrime. So what's nice about isPrime, sorry, I'm reading the problem. Okay. So what it means to be prime is you only have 2 factors, yourself and 1. So let's write isPrime. Let's create the method. It should return Boolean. Let's say num. So you might be tempted to do this. Like let's copy the same stuff. Let's paste it. And then let's say like if count is 2, then return true, otherwise return false. This is like a lot of extra code though, because we already have this method count factors. So there's no sense in us like recreating all the code that counts the factors. So instead of that, let's just say this, int factors equals count factors num. So now our isPrime method runs count factors, that counts the factors, and now we can say if the factors are 2, then return true. It's a little silly to say if factors is 2, it's a little silly to say if this is true, return true, if this is false, return false. Like earlier in the problem, so that we can just say return whether or not it's true that factors equals 2. Oops. And this does the same thing, because if factors equals 2 is true, we return true. If this is false, we return false, which is what we want. And we could make it even shorter by not even saving the return value into a variable. We could just say this, if the count of the factors is equal to 2, return true because it's prime. And like this seems fairly short and easy to read to me. So for me, that's the best answer to this problem. Okay, let's do the last one. So the last one says, find prime larger than. So I'm supposed to find the first prime number that is larger than this one. So find prime larger than. And let's do actually the example input. So I should return an int. I'm going to call this start num. Okay, so it's like I need to search. I need to start at the number larger than this, and I need to test if it's prime. And then I want to test if one larger than that is prime, and I want to test if one larger than that is prime. And I want to keep doing that until I find a prime. So it feels like I want to do something over and over and over again, so that implies that I should be using a loop. But here I don't know how many times it's going to loop, because I don't know when I'm going to find a prime number. So let's use a while loop. So let's create num to test, which is going to be start number plus 1, because I want to start testing for primes at 1 larger than the input number. And so now I can say while isPrime num to test. So is this doing what I want? Let's see, this is going to loop if it's true. But actually, I want to loop if the number's not prime. So I'll say if it's not true, well here, you might think about it this way. So if this equals false. So we'll test to see if the number's prime. If it's not prime, then we'll say num to test plus plus. And then we'll loop back up and we'll test if the next one's prime. And if it's not, then we'll increment it and we'll test if the next one's prime. So eventually, if we ever exit this loop, the only reason we would have exited this loop is if the number were prime. And so now we can return that number. Most programmers don't write if this equals false. What they do is they write bang right before it. The exclamation mark is called bang. The name of this is bang. So we'll say if it's not the case that is prime. So if it's not true that it's prime, increment it, keep doing that in the loop, and eventually we find it. Let's see what the prime number. Oh, cool. There it is. Very interesting. Well, that's definitely something that would have been hard to figure out in another way. Cool. All right. Is that what I was supposed to do? Yes. And that's the end of the problem set. All right. I hope this was helpful. If any of this went a little bit fast, mostly I was showing you answers and I was doing a little bit of explaining about how they make sense or a little bit of modeling the thinking process. But if you feel like you want more modeling of the thinking process, like how would I have come up with this pattern in the first place, let me know. I'll record more videos. Thank you very much. Good luck on the next set.